the number sold times your unit price. Okay, so the revenue is, let's use the McDonald's example again. To get their revenue, if they sell 1,000 burgers and each one costs $1, their revenue is going to be $1,000. Okay, right? So the number sold by the revenue. What the cost is going to be is the same thing. Okay, one other concept we need to get here before we actually start doing the word problems is this, all right? In general, if you raise the price of something, what's going to happen? Actually, who here works at a convenience store or or a supermarket? Okay, good, Luke. Okay, so let's say that they say pop is on sale for $1.99.
Yeah.
What happens?
Well, we normally get a bunch of people in, and then by Saturday afternoon, we're all sold out until Monday.
Exactly. So in general, as soon as you raise the price of something, you're going to sell less of it. So we're going to say, in general,
Raise the price.
well, the same thing. If the price goes up, sales go down. And again, if the price drops, sales go up. And that's called the law of supply and demand if you're in economics, okay? The example I'm going to give for this before I get to the math is Cabbage Patch Kids. You guys probably haven't heard of this, but your parents probably would. Okay, I've heard of Cabbage Patch Kids. What Cabbage Patch Kids are these ugly little dolls, okay, where their heads are like a cabbage patch. The idea of it is they have some with blonde hair, some with brown hair, some with blue eyes, some with green eyes. So you can buy a Cabbage Patch that looks just like yourself. That's the idea behind it. But they look like their heads are cabbages, okay? My daughter has one with a missing tooth because if I told her the story, she got kicked in the face at swing, like somebody had a swing and kicked her in the face, so she's missing her tooth. I told her the story yet. It's a gross story. I don't want to get into it right now. So anyway, my mother bought her this Cabbage Patch, missing a tooth, so it looks just like her. Okay. The idea is then this is wonderful. So when these things came out in the 80s, people went bananas over these. Okay, like mothers went crazy. There would be like lineups in stores on Christmas morning. The Simpsons did a wonderful parody of this, right? Where it's like one of the I can't remember what the dolls are though, right? But there'd be like they would put a sign up on the door saying Friday morning we'll be getting 15 Cabbage Patch dolls. And what would happen was there'd be like 100 mothers, not to be stereotypical, would line up, you know, at 6 a.m. or at 5 a.m. or to get these things, and they beat each other up, and whoever can get their hands on them would buy them. And obviously, this isn't good. Okay, so what the Cabbage Patch Company did, they decided in order to make it so less people would want these, what did they do? Raise the price. Okay, these things were going for something ridiculous like $200 for little. You know what a Cabbage Patch doll is? They're like nothing. Okay, right? Only because people wanted them so badly. Okay, they couldn't keep up fast enough. And you'll see this all the time, right? Like if you're a sports fan, you want to get tickets to the Leafs game on the day of the game. What happens? Okay, the price is enormously expensive. Okay, right? And again, if they want to for against a bad team, let's call them the Leafs again. But for a team there that wants to sell seats, you can drop the prices. And this is just sort of a fact of life. Okay, let's do a nice example to get started on these. All right, because these questions will actually be on here. Example 1 is going to say, example 2, this will be a nice one here, says, a book about vampires and werewolves. I don't know. Sells 10,000 copies. Okay, for those guys who are all listening at the back, sitting in these spots, please stop. Okay. If the price is $25. For every $1 drop in price, $500 more books are sold. At what price will maximize revenue? Okay, so this is like the easy question, but the more difficult one after. The reason this one's easy because there's no cost in here. This is living in a fictional world where the bookstores don't pay anything for the books they sell. Okay, so that's going to affect it. So it says, a book about vampires and werewolves sells 10,000 copies, I should say, if the price is 25 bucks. For every $1 drop in price, they will sell 500 more books. At what price will maximize revenue? Okay, I'm going to make a little chart only for the first example so you can get the logic of this. It's not obvious where the equation is going to come from. So I'm going to make a little small chart that says revenue technically equals price times sales. Okay, so the starting value is going to be what? What's the starting value? What's my starting price, please? Yeah, right? $25. And my starting sales are going to be 10,000. Good. Now that should be no big deal, okay? So if you're still struggling, please try and focus for 1 sec. If the price drops to $24, what's going to happen to my sales? How'd you get that?
Because it's
Right. So if the price drops to 24, I'm going to sell 10,500 books. Okay. Similar to Olivia, sorry Olivia, because I know you got this, okay? If I go the other way and sell 26, so I raise the price to $26, how many books will I sell? Good. Yeah, 9,500. So 26 books is going to be 9,500. So see what we're doing here, right? As the price is stepping by 1 down, the sales are going off the same thing to the other one. Okay, so what's going to be actually what we're changing each time? What's our change here? Because that's going to be our x. And that's y equals my revenue. What's x going to be? Matt? Number of price drops, okay? So I'm going to say then let y equals revenue. You can call it r of x if you want to. X equals the number of price drops. Okay, so I'm going to say then revenue equals price times your sales. Revenue is going to be y or r of x. Okay, can someone who's not in 3M be brave and give me an answer for price? So what's going to happen is it's going to start at $25 and drop by $1 each time. How am I going to write that as an equation? What is going on here?
25 minus x.
Mr. Chason, it's lovely to hear from you this morning. How can I help you? Right here. Is that it? What's that? Does anyone else need to get their option sheet in? There's about half the class here. No, I will not shut up. Yeah, about half the class is good. Yeah, you guys hear that?
Yeah.
What are you waiting for? They say they don't know. They say they want to learn math. Do you want me to tell you names? Okay. Sounds good. Okay. Who needs your offer sheet fixed? Okay, I'm gonna start with the 3Ms. If you're in 3M and you need your offer sheet fixed, you already know how to do this. Do you guys want to go down right now to Mr. Chase and I'll get your offer sheet fixed? Then as you guys come back, one person, you know what I'm saying, will head down. Does that make sense? Right? You know what I'm saying? So when Matt comes back, somebody else leaves, and you come back. Good? Okay. All right, so price, I heard Olivia say correct. I'm still recording this nonsense. The price here, as Olivia said, is 25 minus X. The starting price here is going to be $25. You're dropping by $1 each time, right? So every step you're going to be dropping by 1, so minus 1x. As far as my sales, what's the starting sales and the other one? Go ahead.
It would be 10,000 plus 500.
Close. So he said 10,000 plus 500, and I said very close. What did he forget there?
Mine.
Well, because think if you're dropping your price here,
Oh, yeah.
you're going up by 500, so it's going to be a plus. What did he forget though? 500x, okay? Because what we're going to do is here, very good, by the way. Again, if this were to go to 23, so you'd be dropping twice, you'd be going up twice for your sales. Okay, so there's our equation. We'll do a few of these today to make sure we get that. So just think of this each thing differently. Price goes on the left, so that's your money, right? So 25 minus X, you're dropping by $1 each time. Your sales, you want your starting value, and then what it's going up by, your starting value, and what it's going down by. As we mentioned, these have to be going in opposite directions. Let's say that every time I rose the price, I would sell more books. Would I ever stop raising the price? Never, right? Like I would keep on rising. So they have to be going in opposite directions for this to make sense there. All right, so I want to find the price that maximizes revenue. How would I find the price to maximize revenue? What do I have to do?
Don't they all maximize revenue?
No, because what's going to happen? If you were to actually multiply these out, I didn't. You'd see that you'd be having different numbers here, right? So this is like 250,000.
Yeah. But every time you go up, it's max, and go down, it's max.
Well, how do you know? It'll stop and.
Because if you were to
I'm gonna slow down here. So, if you were to sell at $1, right, you would sell like 1 billion books, okay, right? But the idea is if you sell at 2, you might make more money because, you know what I mean? You know what I'm saying? The ratio works like that, okay? All right. So in order to do this now, what you're going to do is you're going to FOIL out and use the X value of the vertex. So it's not going as fast as I wanted to. Okay, so what we're going to do is here. Okay, guys in the back, please stop. Okay, so I'm going to get a volunteer to FOIL out. Where did I stop at? I can't remember. Riley, I'm going to pick on you though. I don't know where we were. Riley, can you show off your foiling skills, please? I'll do the first one, 250. Yeah. Hey, guys in the back, please stop. Thank you. Keep going. Plus. Oh, goodness. Somebody help me here, guys. 12500, is that right?
Yeah.
Minus 10,000x. Minus 500x squared. So y is going to be negative 500x squared plus 2500x plus 250,000. That's my equation. Okay, so what we're going to do here is I want to, I just folded it out. That's all I did. Okay, so then what I want to do is I actually want to make, now I want to find the x coordinate of the vertex because that will help you to set the price. Once I get the x coordinate of the vertex, that will tell me how many times I've changed my price. Once I have that, then I can just sub it in and actually find what the price is going to be. Can someone be brave and tell me what the new magical way I can instantly find the x coordinate of the vertex is with no difficulty? Luke, go. Just 2a. So think of that as a part of the quadratic formula. This will give you a lot faster. If you like completing the square, you may. I have no issue with that. Yeah. Yeah, you totally could, okay? I'm just going to, it'll still work out the same way here. Okay, for this. Okay, so negative b over 2a. So this is going to be negative 2500 divided by 2 times negative 500, which is negative 2500 over negative 1000 equals 2.5. So I know that x equals 2.5. If you look back to our let statement, what does that actually mean?
Price.
The number of price drops. So that is not our price. We want the price. Can someone be brave and try and tell me how I would get what the price is? Luke, keep going here now.
You sub in 2.5 into the equation.
No, that'll give us the revenue. Okay, I know yes, but it's just going to be the left-hand part of the equation. Because price is just this part, right? The entire thing's revenue. So my equation for price is 25 minus x, which is 25 minus 2.5, which is 22.5. Therefore, the price should be. I didn't do the review sheet, did I? Before I continue here, if you look at the review sheet, it goes through everything. On the back page is a whole pile of word problems. These aren't for marks, but if you're saying I'm worried about word problems, for word problems like this, there's also those speed and river questions and all that. Okay, I'm going to go through another one of these. If you're just joining us, Austin, you didn't get this stuff, there's a review and an assignment here on the front desk before you go. I'm going to hit pause here and then we'll go. We'll do another example. Okay, did anyone do this in grade 10?